So UV-visible spectroscopy আমরা এর আগে পর্যন্ত হোমোঅ্যানুলার অ্যান্ড হেটেরোঅ্যানুলার ডাইন্সের ক্ষেত্রে ল্যামডা ম্যাক্সের ক্যালকুলেশন দেখেছি। আজ আমরা যেটা দেখব ক্যালকুলেশন অফ ল্যামডা ম্যাক্স ফর আলফা বিটা আনস্যাচুরেটেড কেটোনস অর অ্যালডিহাইডস from UV-visible spectroscopy. Now, what are the types of alpha beta unsaturated ketones? They are ketones, they may be acyclic or cyclic. For acyclic ketones, alpha beta unsaturated, the base value will be 215. Cyclic ketones up to 5 member 202. Aldehydes 207 and acids and esters 197. What are the extra substitution? যেমনটা আগে দেখেছিলাম যে আর গ্রুপ দ্বারা সাবস্টিটিউটেড হলে কি হবে বা অ্যাডিশনাল কনজুগেশন থাকলে কি হবে, সেরকম অ্যাডিশনাল কনজুগেশন থাকলে যেমন আমরা আগে অ্যাড করেছিলাম 30, যদি গামা ডেল্টা পজিশনের ডাবল বন্ড, অ্যাডিশনাল কনজুগেশন থাকা মানে কি আলফা বিটা তারপর গামা ডেল্টা, সো ওই গামা ডেল্টা পজিশনের ডবল বন্ডটা যদি হোমোঅ্যানুলার হয় তখন আমরা 30 জায়গায় তার অ্যাডিশন ভ্যালুটা নেব 39 nm, and each exocyclic double bond, if there is a cyclic unsaturated ketone, then if exocyclic double bond as per earlier system same 5 nanometer extra addition. যদি অন্য কোনো সাবস্টিটিউয়েন্ট নিয়ে রাখি, ইটস লাইক অ্যালকিল গ্রুপ বা অ্যালকক্সিল গ্রুপ বা অ্যালকক্সি গ্রুপ বা ক্লোরাইড ব্রোমাইড অথবা থায়োঅ্যালকাইল গ্রুপ, তাহলে সেই ক্ষেত্রে আমাদের অ্যাডিশন ভ্যালুগুলো কী কী হবে। এবার এইখানে কিন্তু মাথায় রাখতে হবে যে যখন আমি আলফা বিটা আনস্যাচুরেশনের কথা বলছি তখন আমার অ্যাকচুয়ালি 4টা পজিশনে এই সাবস্টিটিউশনগুলো ঘটতে পারে, এবং এই প্রত্যেকটা সাবস্টিটিউশনের ক্ষেত্রে যেটা দেখা যাবে কি বিভিন্ন পজিশনে সাবস্টিটিউটেড হলে তার বিভিন্ন রকম অ্যাডিশন হবে। ইটস লাইক ফর এক্সাম্পল অ্যালকিল গ্রুপ যদি আলফা পজিশনে সাবস্টিটিউটেড থাকে তাহলে হচ্ছে গিয়ে 10, বিটাতে 12, গামাতে 17, ডেল্টাতে 17। ফর অ্যালকক্সিল গ্রুপ 35, 30, 70, 31। ফর হাইড্রক্সিল গ্রুপ 35, 30, 30, 50। ফর ক্লোরাইড 15, 12, 12, 12। ব্রোমিন 25, 30, 25, 25। and for thioalkyl group there is no contribution in alpha position substitution, no contribution in gamma or delta, only one contribution if it is substituted in beta position, then only 80 nanometer will be extra added. Now we further proceed with the with some examples of this one so that we can easily experiment what will be the lambda max values of various compounds. These are few examples where we will try to calculate the lambda max value of these compounds. Let us start with the first compound. It's a simple alpha beta unsaturated ketone. So this is alpha, this is beta, and here in beta there are 2 ring residues, right? So for this compound the base value will be 215 nm. Now 2 beta ring residues, দুটো অ্যালকাইল গ্রুপ যেহেতু বিটাতে 2 অ্যালকাইল গ্রুপ substituted in beta position, so for beta position the value of alkyl group is 12 nm. So 2 beta R groups, that's why 2 into 12 equals to 24. Anything else? Nothing else. So the value will be 215 plus 24 equals to 239 nanometer. This is the lambda max for this compound number 1. For number 2, alpha, beta, gamma, delta. Now first we find out where the ring residues or the substituted alkyl groups are present. Here, here and here. So there are 1 substituted beta alkyl group, 2 substituted delta alkyl groups. Base value is also 215 nm, 1 beta R group 12 nm, 2 delta R groups, and that is 2 into 17 was to 34 nm. 2 into 17, 34 nm. Now the total is 4 to 6, 1, 4 and 1, 5 and 1, 6, 261 nm. Now I come to the third one. For the third example, we have a 6-membered cyclic alpha beta unsaturated ketone. We forget about the rest part. What we calculate here is the ring residues and the alpha beta unsaturated. For 6-membered cyclic alpha beta unsaturated ketone, is the base value is same as the acyclic alpha beta unsaturated ketone. So there will be the base value 215 nm. Now for this alpha and beta, here 2 beta ring residues, so 2 beta R group equals to 2 beta R group, that is equivalent to 2 into 12, that is 24 nm. And here is one extra thing, that is this alpha beta unsaturation is exocyclic double bond to this ring. So one exocyclic double bond. For that we add 0.5 nm. So the total will be 239 plus 5 equals to 244 nm. Yes. Now we proceed to the number 4, number 5 and number 6. Let us remove number 1 and replace it with number 4. For number 4, the compound was a 5-membered alpha beta unsaturated ketone. At a glance, we might do a mistake. একদম প্রথম দর্শনে আমাদের একটা মিস্টেক হতে পারে যে 3টে রিং রেসিডিউ দেখতে পারি, বাট ইটস রং. So what are those ring residues or the substitution? Here is 1, here is 2 and here is 3. Nothing about this one. Now the base value of 5-membered cyclic unsaturated ketone is 202 nm. 1 alpha, that is 12 nm, sorry 10 nm. 2 beta R group, that is 12 each, so in total 24 nm. Now the total value will be 202 plus 10, 212 plus 24, 236 nm. Now we proceed to the example number 5. So for example number 5, we again have a 6-membered unsaturated ketone, but there is a cross system. These two double bonds are not conjugated with anyone. Okay, let us draw it first. Here one ring, here one ring, not here actually, here and here. This is the actual compound. So here we see cross system. Now if we have a cross system in our hand, what we have to do? We know that system which has the higher lambda max value will be accepted. Then let us find out which one has an higher. If we consider from this one alpha, beta, and we mark this one as alpha dash and beta dash. Now for A, that is alpha beta, for B, that is alpha dash beta dash. We will try to find out what will be the values. For alpha beta, we have only one substitution. As it is a 6-membered cyclic unsaturated ketone, so the base value will be 215 nm. 1 beta R, 1 beta R substituted, so the value will be 12. If there is any conjugation, nope. So clearly it has the value 227 nm. Now for alpha dash and beta dash, there is 1 and 2 beta substituted alkyl group. So the base value will be 215. For 2 beta R substituted, 12 into each is 24, and there is one more thing, that is this particular alpha dash beta dash double bond is exocyclic to this ring. So 1 exocyclic. So there will be additional of 5 nanometer wavelength. Now the value will be 215 plus 29, that is 244. 5 and 4, 244 nm. So this is the calculation for this one. It was number 5, and now let us take the example of number 6. Let us draw first. Here we can see a mixed system of a 6-membered ring and a 5-membered ring. And how we will calculate this one? Okay. Okay, perfect. Now, so the compound is like that. There is a 5-membered cyclic ketone which has an alpha beta unsaturation. There is a 6-membered cyclic ketone which has an alpha beta unsaturation. Now for number 1 case, that is 6-membered. And there is number 2 for 5-membered. We will calculate differently for 6-member and 5-member ring structure. For 6-member ring structure, we have value of base value of 215 nanometer. After that, this will be the so there is 2 beta R group, that is 24 nm. 2 beta R groups, each carries 2 into 12. Then after, if there is anything else, this double bond is exocyclic to this one as well as this one. So there will be one double bond which is exocyclic to 2 bonds. And again one thing more, there is one alpha alkyl group substituted. So there is 10 nm for one alpha R. One double bond which is exocyclic to this one as well as this one. Now that will be of value 10 nm exocyclic. Thus, what we see here actually, here we see total of 215 plus 24 and plus 10 plus 10, total of 229 plus 10, 239 plus 10, 249 nm. If it is considered to be as a 5-membered ring structure, then what will happen? For this one, we have to take this as ring residues and also this as ring residues. Now here will be only one difference, as we see. The base value will be 202 nm as it is a 5-membered ring structure. Then 2 beta substituted alkyl group, that is 24 nm. Then 1 alpha substituted, it is 10 nm. And here again this double bond is exocyclic to this one and this one, so again 10 nm. The total value will be 202 plus 24 equals to 226 plus 10, 236 plus 10, 246. 226 plus 10, 236, 236 plus 10, 246. Two 15 plus 24, 239. Here it will be 259 actually. The addition was a bit wrong. So these are the values if we consider this particular compound as an example, where we can obtain both one 6-membered or as one 5-membered cyclic ketone with alpha beta unsaturation. We should go with the 6-membered structure as if there is no extra as if there is no any extra conditions, so that we can obtain the maximum lambda max value for this compound, and it will be calculated or it will be counted for this type of compounds. Now for a little bit change, let us take the example number 3 again with a bit change. If there was an extra double bond like alpha beta gamma delta unsaturated, if it was, then what would have been the value? Base value as it is 215 nm. Substitution will be like here, here and here. So where beta, gamma and delta. So For one beta R group, there will be value of 12 nm. One gamma R group, there will be the value of 12 nm. One delta R group, there will be the value of 17 nm. Now extra conjugation. So additional conjugation, it will be, for additional conjugation we all know that the value is 30, but as it is homoannular system, then the value will be 39 nm. অ্যাডিশনাল কনজুগেশন আমরা জানি যে 30 nm টা হচ্ছে তার ভ্যালু, বাট দেখা যাচ্ছে কি এই যে কনজুগেশনটা আছে ইটস অ্যাকচুয়ালি হোমোঅ্যানুলার সিস্টেমের ক্ষেত্রে, সো ইট উইল বি 39 nm. সো মোস্ট অফ দ্য টাইম হোয়াট উই ডু, অ্যাডিশনাল কনজুগেশন 30 nm added, there we do the little mistake. The value will be for this type of compound is 39 nm, and now we get the total lambda max value. How much? 9, 7, 16 to 18 to 20, 25 in hand 2, 3 to 5, 6, 7, 8, 9. 295 nm. So these were the various type of examples for the calculation of lambda max of alpha beta unsaturated ketones. We will try to provide some PDF about the various lambda max values of small groups like alkene group, alkoxy group, hydroxyl group for normal compounds where N to pi star or pi to pi star transition occurs. In the description link I will try to provide that PDF with all these values covered, and for time now this is all.